Hello and welcome back, folks. So, as I promised in the previous YouTube video, what I said is I would cover SQL for you. So what we're going to do first before we dive in to writing a script to interact with the SQL database, firstly, I kind of want to show you a little bit about why we want to do this, or in what cases we would want to do it. And I'm going to show you the different data structures that as a network engineer you'll typically work with, and why those may not be the most useful option when you are working with your data. Okay, so the first one, which you probably already know, is the text file, right? Text file is very basic, and usually if you have, let's say, a set of IP addresses, right, then you could put that into a text file, and you're splitting it up based on the lines, and then for each of the entries that you get out of that text file, you can take those and do something with it. But realistically speaking, when you run the more complex workflows, there's going to be a lot more data that you need to do certain things. As we already observed, there's going to be things like, okay, well, what is the network OS, or what is the model of the device, or maybe we're looking at the software version. There's a lot of different things we could use as validations to assessing whether we should apply certain things to a device based on its various metadata. So text file, if you're doing something basic like just pulling a config and running a config backup, I don't see a problem with that. But outside of that, once you start getting into the more intricate stuff, honestly, it's not that useful, to be honest. Okay. Second thing is the CSV file. This is the Python CSV library, and this is how you write an example of the CSV code. And then when you open the CSV file, it will give you back each of the entries. So obviously the nice thing about this is if you know what your columns are and you know what to expect from each of those columns, then you can write something up and take that CSV data and output it as, let's say, a list. For example, you could convert it to a dictionary if you wanted to, and you could take that data and work with it accordingly. Now, the thing is with CSV data is there's not really any hierarchy to it, right? Meaning that if you need to nest something within your data structure, then you're pretty much out of luck with the CSV file because there's no hierarchy. It's pretty flat, right? If you have, let's say, 5 columns of different fields, you have your, let's say, your IP address, and you have your network OS and maybe your host name, and then maybe how you manage the device, and then a couple different parameters. In some cases, there's going to be hierarchy to the data under the data, right? And so that's where something like YAML could come in, and think of YAML as the easier way of reading JSON. So JSON could be used too. Python works with JSON, but JSON is not as friendly when it comes to readability, and that's why YAML is quite a bit easier for somebody like a network engineer to work with, because it's a lot easier to read. Okay, so right here what I'm showing you is a basic Ansible YAML file, and what you'll see is you see the hyphen here, and you'll also see them use the colon. So in the case of how this would be presented in Python, this would be a dictionary entry. So hosts would be your key, web servers would be your value, and then this represents a list entry. So you'd have a list, and within this list you'd have a key value pair with hosts, and then right here what you'll see is we have a key, and then we have a set of values, but those values are another dictionary. So here we have a dictionary that is embedded within the dictionary here. Okay, and you're probably wondering, when would I use this? Well, one thing you could do is, or one situation I would see this come up is, let's think about hardware for a second. Okay, if you have a single device, so like a 3850, then it's just going to be a single piece of hardware. But what if you had a chassis? Then breaking that down in a hierarchical manner could be beneficial, right? And in this particular video, we're not really going to cover that, but I'm just giving you the example of the benefit of YAML over using a CSV file. If the data is all flat, you can use a CSV file. That's not a problem, okay? So then finally, you have SQL. And there's a lot of different benefits to using SQL over these other three. The first one is that having a SQL database hosted provides centralized access to this database. So let's say whenever somebody wants to update something, they can just talk to the SQL database and they would have that all in one point for everybody else to access. Whereas with the YAML file or the CSV file, yeah, you could take that file and put it on your local machine and you could update things, but there's going to be a synchronization problem to where one person might have the same CSV file, but you make changes to yours, the changes don't reflect across to their files. So if you need this to be a centralized solution to where you want to have a point to where everybody can collaborate and work with the data and make the updates and get the most updated data, then the easiest thing realistically is going to be either a database or it's going to be an API. And realistically, the API has a database on its back end anyway. So databases usually are not the way that you would do it in a production environment, but I am just showing you this as the concept of when it comes to centralized data. Okay, so now let's jump over to SQL. Okay, so there's two. Well, the main SQL database that network engineers or network people typically know is MySQL. Okay, but MySQL has some limitations, and MySQL obviously has its advantages as well. Everything has its pros and cons. Let's be realistic here. But one of the things that you will notice is that Postgres has the ability for table inheritance. Okay, now you're probably wondering, what does that mean, right? Remember the lesson where we talked about classes and we talked about inheriting a base class into a child class. So an example of this would be, let's say you have a class for a base network device to where you know that every network device is going to have an IP address and it's going to have a specific port that you talk to it on and all that stuff. And then you have to break that down even further to where, let's say we want to look at a specific router or specific switch. Then there's going to be attributes specific to a router or a switch, okay? And that's where you could use table inheritance to where you could make a base table with a base set of data points. And then if you wanted to get more explicit and drill down, then having that ability for table inheritance is really nice, okay? So just keep that in mind. As you can see here, there's a bunch of other different features that they have here as well that MySQL does not, okay? So, you're probably wondering, well, which one should I use? And the main disadvantage to Postgres is its learning curve. It's quite a bit more difficult to learn Postgres. The SQL queries are still relatively the same, like the base SQL queries, the base SQL constructs are relatively the same. Obviously, the syntax changes a little bit, but considering the breadth of what Postgres provides you versus MySQL, there's going to be some things that are more difficult to comprehend and understand and wrap your head around. So usually, if you want a simple SQL database, then you can just go with MySQL. If you're willing to go with something that is going to scale quite a bit more in certain cases, then you want to go with Postgres. And you're probably wondering, well, which SQL database we're going to work with in this video. And we are going to do Postgres because I already have a Postgres table built out. Now, I'm not going to be doing any of the special stuff that you would typically see in Postgres versus MySQL, so there's nothing complicated there. Okay? All right, so finally, NoSQL. We'll keep this one brief. So with SQL, one of the things that you have, one of the constructs or definitions that you have within SQL is something called a relation. And basically what that means is there is a set of data that can be related to another set of data, and the way that you point to that data is you have something called a foreign key. Okay? So an example of that, and we're going to see this in our proof of concept when we get into the coding, is a device has a set of credentials, right? Just like a device has a set of hardware. So you could have a table for the credentials, you could have a table for the hardware or the software, and it would be in a separate table. And then you would tie the device to those specific tables, okay? Now, the next thing to note in addition to that is NoSQL, which doesn't really have a predictable structure to it, okay? So, as an example, there's going to be data models in a typical SQL database where the fields are predictable. You know exactly what's going to go into it. In some places, there's going to be fields that you're like, okay, well, this thing, this device, this object has these attributes similar to this other device, but it also has these attributes too. So NoSQL is really more so made for a less predictive data structure. Think of it that way. Okay? That is it on NoSQL. Now, we get to do the fun stuff. Okay? So firstly, we're going to make a file here, and we will put it, well, let's see here. I'm just going to put it in tools. Or actually, I like resources. Resources is a good spot to put a lot of this stuff. So firstly, we need to figure out what tool we're going to use. And actually, before we even get into the tool, I want to show you the database we're going to be working with. Okay? So this is our database. Now, in this video, I am not going to go over how to create the database. And I know this is probably a little cut off there. There we go. So I know that we're not really going to go through this in this video because we don't have enough time. I don't usually make these more than like 30 minutes. So if you want to know how to create the database itself, build the tables and all that, we can have a brief video on that, but I'm not going to do it here. Okay? What we want to know here in this case is how to add entries, how to retrieve the entries, how to delete them, all that jazz. Okay? So this is our devices table. We have our different host names, the management IPs for each of them, the model, the vendor, the function, the credentials, and you'll see here this little thing. This is a foreign key, okay? This is a foreign key that points to the credentials table. And then we have a location as well. I'm not going to go into location, but location's another thing to consider, okay? So, and then if we jump over to credentials, this is what your credentials looks like. So I have a password, a username, and then a group, and then a name. So the name and the group is just a unique way of differentiating, how you classify those credentials. And you can really break that out however you please, however you see fit. Okay. So those are the main two tables of interest here. Now I do have a hardware table, but I didn't break this out yet because I don't want to make this too complicated because then it's going to get a bit more time to grasp your head around. But, just to put a model here for now. Okay. So this is what we're going to be working with. And we are going to come back here and there will be, I don't have it up here yet. Hold on a second. All right. So scikopig2, this is the Python library we're going to use to work with our Postgres database. Okay. So you come down here and you run through all the various different things here. And what you'll notice is how they structure this is pretty simple. Okay, so all we're doing is we're importing psychopig2, and we are importing the sys class. And I'm not sure. Okay, I see what they're doing. Right. So now we're going to write this out. It's going to be very basic. What we're going to do is we are going to write. Actually, before we consolidate this, actually I could do it right here. There's no other code running. Okay. So we're going to make a function. We'll call it, for now, get db entries Postgres. Okay. And there's going to be a couple things that we're going to need. Okay. We're going to need the fields, and the fields is going to be a tuple. And the other thing that we're definitely going to need is we're going to need the connection string. Because if you look back here, what you'll notice is constring. Constring, which is this right here. So we're specifying the host, the database name, the user, and the password. Okay. So we'll just call it constring. And the other thing is up here, we're going to import psychopig2, and we are going to import sys. And actually, there's one other thing that we're going to want to import, which is getPass. And because we do not want to pass our password as clear text, we want to conceal it. Okay. And the connection string is going to be a string, as we know. Okay. And then right here, what we're going to say is firstly create the connection. Psychopig2. Oh, that's why. Psychopig2 dot connect connection string. Next thing we're going to do is we have to get the cursor. And then we're going to execute a command. Okay? So there's a lot of variation that could happen with this. Okay? We are going to do a get statement for now. Okay? In fact, what we're going to do here is we're going to say action, and the action will be a string, and based on that, so you're going to have a select or an insert, or we're going to remove the entry. For now, we're only going to worry about select and retrieving the entry itself. Okay, so we'll say if action, we'll say action.upper, because maybe they get lazy and don't put it in uppercase like they should. If action.upper equals select, then we're going to execute command, say fstring select from, and then whatever our table is. Okay, so this is another thing we're going to have to pass into here as well. We need to know what the table is. What is the table? Which table? Okay, so what is our table here? Let's look at what the table is. This is the database that we're interested in. Okay, the network automation is the one we're interested in. And then these are the individual tables. So we want to retrieve the information from our devices table. So that's where table comes in. And then we will pass in the table name, okay? But what if there is a where clause? Okay, so within SQL, there's a clause where you can say select from this table where, let's say, for example, if we were to look at our table here, where the function is router. Okay. Well, what if we want that clause? For now, let's not worry about that. We're gonna build off of what we have here, and we'll go from there. But we're just going to start with a very simple clause. We are saying get everything. That's what this star means. Get everything from the table name. So we're going to get everything from the device table. That's all we're saying. Okay. And then after that happens, I'm going to say records equals cursor.fetchAll. And in fact, maybe that's only specific to select. I could be wrong. I'll have to check that later. And then, for now, we're just going to print. I'm not going to return. Print. And we are going to print the records. And let's see what this comes out to be. Okay. So then, after we create the function, we're going to call getDB entries Postgres. What are our fields? Okay, what are our fields? Well, we have to define this before we actually call the function. So we need to specify what those fields are. Okay, and so we'll just say device fields here. So it doesn't really matter what we'll call it. This needs to be encompassed within a tuple. Okay, so what are our fields here? We have host name, management IP, model, vendor, function, credentials, created on, and location. All right. So let us write these down, and I'm going to pause this while I write this in. Okay, so now we have our fields specified. The next thing we need to specify is the connection string. Okay, and that's going to be an F string. And let's check out what the example is here. So this is our example. So let's copy this, paste this in here, and we need to change all this. So firstly, we'll just say 127.0.0.1 here. We can say localhost 2, but I'm just going to use the IP. Database name, as we know, that is network automation. Okay. Postgres, user Postgres. Yes, my user is actually Postgres. Password. Okay, so I told you earlier that we added getPass. So what we're going to do here is we're actually going to make this a get. We're going to call the getPass function to pass in the password there. Okay. And then after we specify those two, now we can pass in the fields, device fields. That's the first thing. Okay. And then the next thing we want to do is pass in our connection string. And then we have our action. Our action is going to be select, and our table is going to be devices. Okay. And then we can run that. So let's see if we get any errors. Oh, that's the wrong script. That's why we want to run this one. Oh, and I do not believe I have psychopag 2 installed yet. That's why. Oh, one other thing to note for anybody who's using Mac, do not try and install this. You're going to have some problems doing that. There's another library, and I think it's called Binary. I need to check that. Okay, so you're going to say, if you want to look up to see what's available in pip, just say pip search. We're going to say pip search, and we're going to search psychopag 2. And there's a library Copy to binary. That's what we want. Yeah, so I confirmed that. So now let's install that. And we should not have any issues installing it. Okay, good to go. Good to go. Now let's rerun this. All right, let's see what's going on here. We go, okay, yeah, so for this one, we want to say from getPass, import getPass. It's just specific to this particular library, okay? And then we should be good to go. Let's try it out. And there you go. We now have a set of entries for the devices that are currently stored in the database. Okay. Now, the next thing that we want to do is, you're probably wondering at this point, why are these here? And what you'll notice with the output here is it's not giving you what the fields are. Okay, that's a problem. We want to have both the fields and the values. So taking this and putting it into a dictionary format would be extremely beneficial. Okay, so what we're going to do is we're going to turn this into a list, and in that list is going to be a dictionary comprehension. So list, dictionary, and then we're going to zip the fields together, fields and L. Okay, what is L? For L in records. So I'm just going to explain this to you, break it down for you. Okay, what are we doing? So for L in records, this is just a loop, right? So L is your entry, and then your field is whatever's here. So it's going to map the field to the value of each of the entries. And then, because this is in a list format, because we have multiple entries, we're going to wrap this within a list structure. So it's going to return as a dictionary, and then that dictionary is going to be stored within the list for each entry. Okay? So let's rerun that. And there you have it. So now we have everything from our devices table that is presented to us, and we can take this and we can feed it into running, if we want to get the commands off of a device, we can take this information, run the commands, and we can also filter it. Let's say based on our model, we could filter it based on what the vendor is. And we could extend it even further to saying, if it's a specific iOS version, we can run it on that. And, there's just a bunch of different things you can do because you have so much metadata to work with. Okay? So that is the whole video. Hopefully you enjoyed this. We are going to be doing another video on adding and deleting and things like that. For now, this is just focused on select, okay? Retrieving the entries within the database. Hopefully you enjoyed it. If you enjoyed it, like, share, comment, all that stuff, okay? Have a great rest of your day, and I will talk to you later.